Okay, good. So good morning. Today, we will be talking about back to the future, hacking and securing connection-based OAuth architectures in Agentic AI and integration platforms. This is a joint work between our team from the Chinese University of Hong Kong and Samsung Research America. My name is Wing Lau, and this is Kai Xun, okay? And here is the outline of our talk. In the next 30 minutes or so, I will first provide some background about integration platform, Agentic AI ecosystems, and then explain the crux of the new security problem, namely the new security challenges in this emerging OAuth-as-a-Service architecture, which are being adopted by a lot of Agentic AI platforms in the industry. Then I will give a summary of our key findings before passing it over to Kai Xun, who will cover all the technical details, as well as the case studies and empirical results. Okay, so even before the rise of Agentic AI, actually a user can already use integration platforms built by big name providers, such as those shown here, Amazon Alexa, Google Home, or Microsoft Power Automate, or even ChatGPT, okay, to control external applications, or a.k.a. the tools, in order to complete some tasks or orchestrating more sophisticated tasks, okay? And now, as we enter the era of Agentic AI, we will expect, instead of just a handful of big name integration platforms, there will be many, many more third-party AI agents developed by third-party developers, okay, that help the user to do tool control and orchestrations. And in fact, in the industry, we already see a lot of companies who are busy positioning themselves to build so-called the AI agentic platform, okay, or Agentic AI platform to help third-party developers to develop this many AI agents. So with that setting, now a user can delegate tool control and orchestration to both big name integration platforms as well as third-party AI agents, okay, to complete or automate increasingly sophisticated tasks. But we need to make sure only the authorized agents or the integration platform, okay, can access those users' tools on behalf and control them on behalf of the user. So we need delegation authorization. And in the industry, OAuth is the standard for delegation authorization. And as such, both integration platform as well as third-party agents need to deal with relying on OAuth, okay, to do two-use authorization. However, we all know that OAuth is not trivial, okay? In particular, to apply OAuth to these new use cases to build a secure system, okay, it's not as easy as it sounds. And in fact, last year here in Black Hat USA 2024, we already shared our findings. A lot of new OAuth-related vulnerabilities when they got applied to integration platform. And in particular, we found 3 types of new attacks through so-called based on false account or account mislinking, okay, which will result in one-click account takeover or privacy leakage of the tools. And out of the 25 platforms that we study, 24 of them are found to be vulnerable to at least one of those new attacks, okay? And the affected domains, those platforms, actually span across different application domains, including smart home, Internet of Things IoT, virtual voice assistants, workflow automation, as well as LLM services supporting plugins, okay? And many of those vulnerable platforms actually have more than 100 million active users. Okay? So this actually demonstrates that it's not easy to get OAuth right. Okay? Even the big names had problems. And we would expect, as we see the proliferation of Agentic AI, namely that we will see many, many more agents developed by third-party developers. Okay? The problem will get worse. Because after all, the third-party developers are not as resourceful or may not have the technical expertise in OAuth like those big name providers of the integration platform. Okay? So in order to relieve the third-party developers from these OAuth intricacies, there is a paradigm shift towards so-called the OAuth-as-a-Service architecture, okay, in the industry. And under this approach, we can offload the complexity of OAuth token management from those large number of third-party agents to a secure token manager, okay, run by the Agentic AI platform. So in the industry, we already seen an example. For example, for Microsoft, now they offer at least 2 secure token manager under the name of Bot Framework Token Service or Credential Manager, which are used to support the Agentic AI platforms, as well as the integration platforms, respectively. And elsewhere, we also have other companies and startups which have similar offerings, which use OAuth-as-a-Service architecture to facilitate third-party developers to build their agents easier. Okay? A typical offerings, including the software development kit, a development portal, and then a token manager run by the company. Usually, the company will refer their offering either as a AI tool calling platform, or AI agent toolset, or AI app development platform. It is very common that those offerings will also include pre-built software modules to support popular tools, as we show here, and as well as some of those platforms also have their own first-party agent applications under the platform. And this OAuth-as-a-Service architecture is also relevant for MCP, the popular Model Context Protocol. Okay? And after all, MCP was originally proposed by Anthropic to support to use in large language model, LLMs. Okay? And in the original MCP architecture, the MCP client, which hosted by some thing like a cloud desktop, actually, will be responsible to store and manage all the tool tokens dealt with the OAuth complexity. But now in the industry, there's already a new proposal in the MCP community, okay, which propose to have to shift, offload all those tool tokens management from the MCP client to a token manager implemented by a single MCP server. Okay? So in that sense, this OAuth-as-a-Service actually pop up everywhere. So with that one, sounds like OAuth-as-a-Service sounds good. We can centralize some of the complexity, give it to the more resourceful builder to implement it. So everything sounds okay, but actually it's not as good as it sounds. Why? Because the new OAuth-as-a-Service architecture also brings its own security challenge. In particular, okay, before this architecture, an integration platform, all they need to do is to take the role and implement OAuth client under the standard framework. Actually, the developer can mostly follow the OAuth standards, except those caveats that we disclosed in last year's Black Hat, okay? And then they can follow the standards, build a secure system to manage the OAuth tokens. However, under the new OAuth-as-a-Service architecture, the functions of the OAuth client under the standard framework got split between the two entities, namely the third-party AI agent and also the secure token manager, okay? And the problem is that how these functions to be split actually is beyond the scope of the OAuth standards. And as a result, different agentic AI platforms need to roll their own proprietary designs. And not surprisingly, we find that they have committed mistakes, actually new critical OAuth-related vulnerabilities. And in fact, what we'll be sharing with you or explaining is that about our new findings on this problem, okay? And in particular, what we find is that several classical web attacks, okay, which were carefully addressed by OAuth standards, has now manifest under this OAuth-as-a-Service architecture. And in particular, these classical web attacks are things like section fixation, open redirect, as well as different types of confused deputy, okay? But they now resurrected in the context of OAuth under this new architecture. And in our study, across the 7 different platforms or vendors of agentic AI platforms, we found numerous instances of vulnerabilities under the context of cross-user attack, cross-agent attack, and cross-tool attack. And all of them will lead to account takeover of the victim. Okay? So now I have provided the background, so I will hand over the floor to Kai-Shun to go over the technical details. Thank you.
Hi, everyone. I'm Kai-Shun Luo, and we'll be covering the technical details. Let me start with some basic OAuth terminologies here. So traditionally, if you build an agent that needs tokens from the tool Dropbox, you need to set up an OAuth client for managing tokens. And the tool Dropbox would operate an authorization server that issues those tokens. So your agent, the OAuth client, will send the tokens back to Dropbox resource servers for API calls. But in this new paradigm of OAuth-as-a-Service, the OAuth roles remain, but because of the split of the OAuth client role between the agent and the token manager, the key problem here is how can these two entities negotiate? How could they coordinate? There are 2 potential solutions here. So the first solution is that we just chain 2 OAuth flows side by side. So we repeat the OAuth pattern between the token manager and the tools, and let the agent and the token manager also talk in OAuth. So the benefit of this approach is that the agent now only needs to establish OAuth with the token manager. But the limitation is also obvious. The agent still needs to implement the OAuth client and manage the token securely. People would call this pattern brokered OAuth. The other solution is that people try to invent something new. So something that's based on this OAuth connection concept, which is a proprietary add-on that's introduced by some of those OAuth-as-a-Service providers. The high-level idea here is that instead of returning tokens, which are crucial secrets that the agents need to keep secure of, the token manager would simply return an ID for each token. That's the connection ID. So the key benefit of this architecture is that the OAuth logic is fully abstracted away from the agent side. And the token manager would fully handle the token's whole lifecycle for the agent. We call this architecture the connection-based OAuth architecture, and it will be the focus of our talk. Well, actually, all of the vendor examples we mentioned so far are adopting this second approach. More formally, a connection is defined as a pre-configured handle for a managed OAuth token. So at the minimum, it will encompass the information of a 3-element tuple: tool, agent, and user. This is because these are the necessary information to fulfill the basic use case. that an agent calling a tool like Dropbox on behalf of an end user. So this 3-element tuple is tracked as metadata within a connection and governed by a connection ID like a database primary key. And what's inside this connection is this managed OAuth token. But before we dig deeper on how OAuth actually works with this connection concept, let's step back a little bit and first figure out how an OAuth flow is supposed to work without connections. And under the hood, it goes like this. So first, the end user will be involved in OAuth, typically with a web browser. When the user clicks the connect button to start OAuth, the agent backend, now implementing the OAuth client, would issue an OAuth authorization URL and pass it back to the browser. So this is referred to as OAuth URL for short. Following the OAuth URL, the browser would hit dropbox.com/authorize, which is Dropbox Authorization Server. And the end user would need to log in Dropbox and provide his consent to click an authorize button. But this explicit authorization is not always required. For example, if you've logged in and authorized it before, then the next time you encounter the same tool, then very likely the consent will be gone through automatically. Remember this setting because it will be the building block of many powerful stealthy OAuth attacks. And after this authorization step, at step 3, Dropbox will return an authorization code and gets it delivered via the browser through a redirect to a callback that's set up by the agent backend. And during this process, there will also be another OAuth parameter involved called state that can be used to keep track of the state in OAuth. And then comes the code exchange phase, where the authorization code will be exchanged for an access token that's to be stored at the agent backend. So that wraps up the OAuth dance. And because each agent can have its own end users, so the user session here in the browser will be used to tie the tokens to a particular user's identity. OK, so now let's move on to the new connection-based OAuth architecture. There are 3 phases in the call flow, namely pre-OAuth, OAuth, and post-OAuth. Pre-OAuth, the agent will first request for a new connection, and information about the 3 elements in the tuple, tool, agent, and user, will all be passed to the token manager. And the token manager would generate a new connection, but it will be an empty connection for now because the OAuth part is not done yet. This new connection ID and also the OAuth URL will be returned in the response. So following the OAuth URL, an OAuth flow will be established, and eventually, an access token will end up occupying this empty slot in the connection. And post-OAuth, the agent would use this connection to make authorized API calls. After retrofitting this connection concept to OAuth, this is how the whole picture will look like. So this is the traditional OAuth from step 1 to step 5. And now we place this add connection part within the OAuth flow. And what we get here is how the connection-based OAuth will work in normal coordination. So from the agent's perspective, whenever it receives a request from the end user to start OAuth, it would just query the token manager to generate an OAuth URL, and then pass the URL back to the user, and then wait for the user to complete OAuth. And from the token manager's perspective, the connection concept would actually manifest as an authorization session in the OAuth flow, so that it could keep track of the connection even in the user's browser. And usually, this authorization session will be maintained by the state parameter in OAuth. And from the end user's perspective, the user experience is no different from the traditional OAuth. But it turns out that this normal coordination also is an insecure coordination by design. Why is it the case? So now I'm starting with the first attack. As an end user of an agent, I would expect that my authorization should not go to another end user that's served by the same agent. But in reality, this expectation is invalidated by an attack called session fixation. So session fixation is a classic attack in web security where an attacker can fixate a session ID of his own to a victim and force the victim to authenticate under that session ID. In this way, the attacker could take over the victim's account. In connection-based OAuth, recall that the connection would manifest as an authorization session during OAuth, so we actually already have this session concept here. But what about the fixation part? When an attacker initiates OAuth, an OAuth URL is returned, which signifies an attacker's connection or session. So now what the attacker would do is that it would simply share this OAuth URL to the victim, say dropbox.com/authorize with some OAuth parameters here in this case, and then let the victim go through the rest of the OAuth dance automatically. Because here, the authorization session belongs to the attacker, so the victim's OAuth tokens would eventually get linked to the attacker's connection. And as a result, the attacker could take over the victim's tool account like Dropbox access. So that's how the session fixation attack will work. And we found 5 vendors vulnerable to this attack. In a session fixation attack, it is the attacker that initiates OAuth, but it is the victim that actually completes OAuth. So to defend against this vulnerability, the high-level idea is that we need to verify the user that initiates OAuth is the same user that completes OAuth. More specifically, it is to enforce that it is always the same person that trying to generate this OAuth URL and do the follow-up OAuth dance. But to actually implement this high-level defense idea, it's still a little bit tricky here because, again, we face the split between the token manager and the agent backend. So the original redirect step in OAuth cannot determine which user actually completes OAuth because it will redirect to this decoupled token manager. The token manager is designed to only handle OAuth. It is agnostic of all of the other agent-specific logic, for example, user sessions. So here, the idea of the fix is that the token manager would need to additionally redirect back to the agent backend. And then the agent backend would extract the user ID out of the user session for further verification. So we call this defense the post-redirect pattern. And here we offer 2 alternative implementations of this same defense idea. I'll skip the finer details for now, but feel free to review them later. So the key takeaway here is that, as you can see, even in this connection-based OAuth architecture that aims to completely decouple OAuth, the agent backend still needs to take some of those OAuth responsibilities for security purposes. OK, so to wrap up, we see this session fixation possibility in connection-based OAuth. And actually, a similar pattern can also be observed in MCP if this downstream tool authorization is enabled by simply distributing an OAuth URL. And the session fixation attack also applies if you do not verify the user identity consistency. So to recap what we've covered so far, there is this session fixation attack and a corresponding defense, which relies on the concept of post-redirect. But what if this post-redirect pattern failed to serve its purpose? So now it's time to bring up the concept of channels. Many Agentic AI platforms would let developers to publish their agents in various channels. So besides regular websites, you could also deploy your agents to multiple instant messaging apps as bots, say your Facebook Messenger, Slack, Telegram, and so on and so forth. So in AI agents, the browser may not be the only user agent or the only channel involved for user interaction. And because of that, this whole idea of post-redirect may not work as expected. Because here we require the token manager to post-redirect to the agent so that it could verify the user's identity. But in this complex channel use case, say if it's an instant messaging app like Facebook Messenger, redirecting to this instant messenger app itself is easy because that's offered by the deep link feature that's supported by modern operating systems. But here we are requiring to redirect to the exact agent or bot that's running inside this instant messaging app. That is hard because it will require custom support for each channel. So this will make this post-redirect defense hard to implement. And to tackle this limitation, the high-level idea is that we could learn from how people develop the cross-device flows in OAuth. So when you log in to your smart TV using your mobile handset, there is a similar gap between the devices that would render the OAuth redirection inapplicable. Just like the gap we are facing now, we are facing here between the agent and the token manager. So one of the solutions for this session fixation defense in this instant messaging channel scenario is that we could either directly adopt existing cross-device flows in OAuth, or maybe retrofit some cross-device design patterns to the most standard OAuth flow that we covered in this talk. For example, in Microsoft Copilot Studio, it involves the end user to manually copy and paste a 6-digit PIN to bridge this gap. which may look a little bit clumsy, but it is the most practical fix so far. So now I'm going to talk about the second attack called Open Redirect. Open Redirect is another classic web attack where a website's redirection would accept a user-controlled input, and that can be used by an attacker to redirect the end user to an untrusted location. In connection-based OAuth, Open Redirect vulnerabilities can actually occur when token managers try to mitigate session fixation. So it's the previous attack. It's trying to mitigate the previous attack. Recall that the implementation of session fixation defense requires the token manager to issue a second redirect to this agent backend. But how does the token manager know which exact endpoint at the agent backend should it redirect to? So a common approach here is to pass this information from the browser. And this could open up Open Redirect possibility, because now we have a user-controlled input. So what the attacker would do is that it would initiate OAuth, but for the session fixation defense part, it would specify an attacker-controlled location as the post redirect, instead of any prefilled values. And then like session fixation, the attacker would just simply share the OAuth link to the victim, and then the victim would go through OAuth. And now because of the session fixation defense, this token manager would redirect to this attacker-controlled location. And that's how the OAuth credentials could be leaked to an attacker. For Open Redirect, we have found 2 instances of attacks, both in Microsoft. It turns out that Microsoft only checked the post redirect URL with wildcard. So as a result, we could point the post redirect to a place with either a cross-site scripting vulnerability or with a post message vulnerability on Microsoft domain, which would all allow the attacker to eventually harvest the victim's OAuth credentials. So now it's sample time. Let's see how to leverage this Open Redirect with cross-site scripting to steal Outlook emails in Microsoft Power Automate and Power Apps. So first, we are lucky enough to find a cross-site scripting on ideas.powerapps.com. It is a domain for the Power Apps community forum. It will share the same root domain, but different subdomain as the OAuth post redirect URL. So the attacker could inject a malicious JavaScript as a post comment. But here we're not going to steal this Q&A website's cookies directly because it will be low impact. Instead, we would forward any URL parameters to an attacker's site. And we would couple it with this OAuth part of the vulnerabilities. So during OAuth, here we start a new connection. And the attacker would set this post redirect URL to the URL of that cross-site scripting page. And because the token manager is in Microsoft, it only does wildcard matching. So this new manipulated post redirect URL would also be accepted. And now what the attacker would do is that it would copy that OAuth URL and then compose a phishing email and then send it to the victim. And then the victim will be tricked to make a click. So the victim would jump to the manipulated post redirect location automatically, which would trigger the malicious JavaScript that would exfiltrate the victim's authorization code to the attacker. So this is how the victim's authorization code could be leaked. And after that, an attacker can redeem this stolen code for an access token and will result in this stolen connection with the victim's token. So next, the attacker would use this stolen connection with an Outlook email tool that would be used to leak emails out of the victim's mailbox. And here we can see this email being leaked. So now, mission complete. So as a defense, it will require that the token manager strictly verify whether the post redirect is allowed or not, or not to even expose this post redirect URL to the front end, but have it pre-configured at back end so that there will be no more user control input for the redirect. So to reflect on this Open Redirect attacks in OAuth, there is actually a common source of Open Redirect already in OAuth, which is this first redirect from Dropbox to this token manager or to the OAuth client. But here we'd like to emphasize this post redirect from token manager to agent backend when implementing this session fixation defense, which could further expose Open Redirect vulnerabilities. Next, let's move on to a new category of attack called confused stability. In traditional web security, confused stability is like a very broad attack type where a privileged entity would get confused by an attacker to intentionally forward a request. So in OAuth-as-a-Service, we have identified 2 confused stability scenarios here. So what if my authorization that's intended for one agent would be granted and normally granted to another agent? Or meanwhile, what if my authorization for one tool will be forwarded by the token manager to another tool? So let's first focus on the confusion between different agents. So thinking about this business model of OAuth-as-a-Service, from its angle is the more I can help the agent developers ease the OAuth burden, the better. But besides managing OAuth tokens, what else can I offer? Here comes the concept of pre-registration in OAuth. So traditionally, before a user can actually run OAuth flows, the agent developer needs to first talk to the tool first, talk to Dropbox, that will request for a unique pair of ID and secret. So this Dropbox-issued client ID is used in OAuth flows to identify the agent. But in OAuth-as-a-Service, what we're seeing here is some providers would go through OAuth registration with a lot of these common tools like Dropbox, Outlook, or GitHub, or Google Calendar, and the agent developers don't need to do so. So now, instead of having each agent registering its own client IDs, 2 agents or multiple agents would share the same client ID offered by the token manager. But this design has a critical flaw that could be elevated to an attack, which we call client ID confusion. Let's say, as an end user, I first authorize Dropbox in an agent that I trust. But behind the scenes, what I'm actually doing is granting that access, granting that consent to the Dropbox client ID at the token manager. So later, when I stumble upon a malicious agent, also wanting Dropbox access, although intentionally I want to stay alert, but under the hood, I am still authorizing this same client ID of the token manager, which I already granted consent to. So the Dropbox access will be automatically granted to this malicious agent. And as a defense, we will require that the token manager rather not offer shared client IDs for the agents. Instead, just let each agent register a client ID for themselves. The final attack form is confusion between different tools. So last year at Black Hat, we shared an attack vector in integration platforms that's called cross-app OAuth account takeover, or COAT. The high-level idea is that an integration platform, as a confused stability, could be disclosing the victim's authorization code as a benign tool, like Dropbox, to a malicious tool. So this attack would require that the platform itself has an open marketplace so that the attacker could infiltrate a malicious tool. But now, with this multiple third-party agents supported by OAuth-as-a-Service, an attacker can always use a malicious agent that carries a malicious tool to target a benign tool in the victim's agent. So now the malicious tool's existence will not depend on an open marketplace of the victim's agent or platform. And we found 6 vulnerable instances across the industry that are susceptible to this cross-agent version of the COAT attack. As a case study here for this cross-agent COAT attack, we have found a severe vulnerability in Microsoft Copilot Studio. So in Copilot Studio, every agent is called a Copilot. And interestingly, Microsoft has extended this token manager to support user authentication. So in other words, you could use this token manager for more fine-grained access control to configure who can access your agent. As a result, what this cross-agent COAT attack would become is I can use a malicious Copilot and configure a malicious identity provider to log into arbitrary, well-authenticated Copilots on the internet. And to launch this attack, first, the attacker would just try to log into victim's Copilot to try some luck. Unfortunately, he will be blocked because the victim's Copilot is only configured to be used within the victim's own tenant or own organization. So the attacker is an outsider, naturally cannot log in. But what the attacker would do is that it would go set up these malicious authorization server endpoints in his malicious Copilot, which would target the victim's tool or identity provider in the victim's Copilot. So this coincides with the setup of this cross-agent COAT attack. And now the attacker will go fetch a fresh OAuth URL with his malicious Copilot that will conduct OAuth with this malicious identity provider. He would send this URL to the victim and lure him to make a click. And once the victim makes the click, he will be automatically redirected and to leak his OAuth credentials of his Copilot to the attacker. Then with this stolen OAuth credential, the attacker could obtain an access token that will lock himself into the victim's Copilot under the victim's identity. So essentially, with the victim's one single click on a hyperlink, an attacker without any special privilege could launch cross-agent, cross-tool account takeover. And in the context of Microsoft, it is the takeover of the account that's used to authenticate the victim's Copilot in the victim's tenant. And moreover, the impact here is not limited to logging in as victim because of the powerful capabilities of AI agents. More juicy are all the data and resources in your Copilot that an attacker could enjoy. So this would include, but not limited to, permissions, knowledge sources, and other tools. That's all configured behind the gate of your Copilot's OAuth. And as a defense here, we require that the token manager would differentiate not just the tools inside the particular platform or agent, but also across agents. So it will require a globally unique identifier for each tool in the OAuth parameter called redirect URI that could be used for further tool consistency matching. OK, so to summarize what we covered so far, we first discussed the scenario of cross-user attacks. We introduced two attacks. Session fixation happens because of the decoupled token manager. And open redirect happens when people fix session fixation incorrectly. And we then introduced a cross-agent confusability attack called client ID confusion, and another cross-tool confusability attack called cult, also with this cross-agent impact. So we can see, indeed, classic web security or OAuth threats would re-manifest themselves in this connection-based OAuth architecture. And these back-to-the-future attacks enable tool account takeovers as easy as a single click. Besides, we also briefly touched the concept of agent publish channels, and we discussed why session fixation defense may not work for session channels and provided some alternative mitigations. To make the world a better place, we investigated 7 leading vendors across the industry and found 5 instances of session fixation, 2 open redirects, 3 client ID confusions, and 6 cross-agent code attack, which adds up to 16 vulnerable instances. We follow the common industrial practices for responsible disclosure. And for some vulnerable vendors, including Microsoft, Arcade, and ByteDance Codes, we had in-depth discussions and meetings with their engineering team to help them better understand the security issues and also better fix the problems. We'd like to take this chance and thank these vendors for their coordination and responsible fix. So this is the taxonomy of our attacks, covering 3 attack scenarios, 4 attack types, and the dedicated defense for each attack type. We'd like to conclude our talk with some key takeaways here. So firstly, emerging OAuth-as-a-Service architectures indeed bring convenience to AI agent development, but it could also introduce or reintroduce classic vulnerabilities when inventing this proprietary OAuth connection concept. Secondly, as an end user, you may trust your agent, but you may not be aware that there is this token manager behind the scenes, which is actually a third party that you don't recognize, right? And this token manager is, in fact, part of the OAuth-as-a-Service architecture that's adopted by Agentic AI platforms and is potentially vulnerable. And because of this vulnerable token manager, agents may unknowingly expose end users to impersonation and unauthorized access. So as an actionable takeaway for agent developers, please review your AI stack and see if you're using one of the insecure OAuth architectures. For OAuth service providers, please fix the security issues ASAP. These are some of our references. And also feel free to take a look at our previous work if you are interested. That's all for our talk. Hope you enjoyed it. Thank you, and we are ready to take questions.
So I think we are running out of time for questions, but we'll be here and also go to the rep room. Go to the rep room, and then we can discuss there. Thanks a lot. Thank you.